Good morning, student. Let's start today's class. Okay, and in today's class, we are going to study the rest of passive cooling techniques, or the remaining part of the passive cooling techniques. Okay, today we will discuss about how we will cool our living room by using paints. Okay, if the external surface of the building are painted with such color as have minimum absorption of solar radiation, but the emission in the long wave region is high, then the heat flux transmitted into the building is reduced considerably. That means we choose such colors of paint which uh, ab- which uh, which have a low absorption power of solar radiation but have a high emittive or a high emittive power of long wave radiation. Okay, such color it you know if we paint in basic in commonly if we paint white color, it didn't absorb solar radiation, and if we paint black or darkish color, it uh, absorb more and more radiation. Okay, so if we whitewash, okay, whitewash our building, okay, then the reflective or the uh, reflective when, okay, in whitewash, though it has a lower reflective than aluminum. That means in shining of aluminum, reflective capacity is more than the whitewash reflective capacity, but will stay, but it will stay color when exposed to solar radiation. Okay, it will stay color when exposed to solar radiation because it is very high emittive as low at low temperature. Okay, that means uh, we should use whitewash or white color or bright color, okay, to cool our building. Okay, and another way of cooling is evaporative cooling. Okay, evaporative evaporation of water takes place by the conversion of sensible heat into latent heat. That means evaporation means, what do you mean by evaporation? Evaporation is that but that the water vapor, okay, cool down the air. Okay, this is the process of evaporation. Okay, here the conversion of sensible heat, that means which heat we feel into the latent heat. Okay, that the the heat we feel into the convert into the latent heat is called evaporation. Okay, and in evaporation the process is involved of water or sprayer of water vapor and cool down the air, or cooling the air using water sprayer. Okay, a large amount of heat is removed through this method. Okay, this is very common. Okay, the most commonly employed evaporation cooling system is a window unit air cooler, which evaporate pads, okay, a fan and a pump. Okay, in our daily life we use coolers, okay, in our home. That coolers have one evaporative pads, okay, which wet and through which air come by cooling itself, okay. And it has a and the cooler has one fan, okay, and one pump to pump the water into the evaporative bed, okay. That's window unit air cooler, that is window unit air cooler, okay. then uh, then central air cooling system with a spray chamber and a blower are also used for large building, okay. This is the air cooler or the window air cooler unit is used in domestically, okay, but in commercial area we cannot use individual units, okay, to cooling or to place and individually placed one unit in one window. So we use a sprayer chamber, okay, through which the air pass the central air or the air of whole building pass through the cooling chamber or sprayer chamber and cool down and we get cool air, okay, or cool air, okay. But in many work areas excessive humidity air and and also by passing the air through a water sprayer, the air carry water vapors so that the humidity, okay, the humidity means the amount of water present in our environment, the humidity is increased inside the building, and this humidity increased is not acceptable in some of the cases or some of the scenario, okay. in that scenario we can use a form of a rock bed, or we can use the heat exchanger, okay, and that heat exchanger has been implemented in the form of a rock bed. That means for for reducing the humidity in the cooled air, we use uh, we use a heat exchanger, and that heat exchanger, okay, that exchanger may be or implemented in the form of a rock bed, okay. And now see what is rock bed cooler, okay. Here what happened, this is the rock bed cooler, okay. Here what happened, there are two rock beds, okay. This is rock beds, there is two rock bed, and this rock bed is separated by one air ventilation or one air passing wedge, okay. This air, okay, coming from the building, okay, and both two chambers of rock bed have two water sprayer, okay. And these two rock beds you or worked alternately. That means if this bed is used, then this bed is cooling, and if this bed is used, and this bed is used at the time this bed is cooling, okay. That means when the air from the building coming from and this fan force the air into the rock bed chamber, okay, the rock bed is what cool down briefly by the water sprayer, okay, and this air pass through the rock bed and air out, okay, and air out to the building, okay. When this rock bed is used for cooling, okay, at that time the another rock bed is cooled itself after using it for cooling, okay. That means the two rock bed are there for alternating operation, okay. When one rock bed is used, another rock bed is cooled itself, and when the other rock bed is used, the first one is cooled itself, okay. That is backup process, okay. So and uh, and why this rock bed heat exchanger didn't give so much of moisture to the cooled air? Because this rock bed, okay, this rock bed works alternately. That means after spraying of water in the rock bed cooled, okay, the rocks are cooled and also dried. That means that means that much of time given to the rocks to dry itself and cool itself, okay. So after that the air is passed. That means since the air is passed through the cooled rocks and also dried rocks, that's why the cooled air coming from the rock bed have very small amount, very little amount of water vapors, okay, or moisture. And the problem, this is the advantages, or this is the advantages that we get low humidity water air from rock bed. But there is so many problems are there, okay. One major problem common to all these evaporation cooling system is the low operation efficiency during the humid part of the summer. When the peak summer are there, the humidity level of the surrounding environment increases. At that time or at that humid summer, these evaporation uh, systems didn't work efficiently, okay. So a convenient alternative, so a conceivable alternative for such high humid regions is desiccant cooling. That means for solving the problem, for solving or for revoking the problem, we can use a desiccant cooling. Desiccant cooling means we can use the material which uh, absorb uh, water particle before cooling the air, okay. Like the material silica jelly. You heard about silica jelly. The silica jelly is the particle which absorb moisture, okay, from the air, okay, and after absorption of moisture from the air, that air cooled and give to the building, okay. But the use of desiccant for natural cooling is limited by the non-availability of the material suitable for large scale of use of that type of cooler. That means due to the limitation of or limited availability of the desiccant material or the silica jelly, we cannot use these techniques for large scale of operation, okay. So that use we use two types of coolers, air coolers, evaporative air coolers and evaporative water coolers. Okay, so these two we will discuss in coming classes. Okay, thank you.